Hello all. Today I would like to introduce you to my dear Dutch colleague, Paul. Paul has been 34 years in the water business, going through every possible role that you might think of. And lately he's into the acceleration of innovation, a job that he knows to do best, better than most. Paul, hello, how are you?
Hi, Christos. Hi. Thank you for this opportunity. It's very nice to talk to you again. Yeah, great.
You have been pretty busy as of late, working with innovation in the water sector. You might want to tell us a little bit about it and your thoughts in general about the topic?
Well, I've been doing this for, like you said, for 34 years, right? And so I understand the challenges in the water industry. Like a lot of people actually understand those challenges. And we're saying we are a very conservative industry as a water industry, but actually that is not true. I think the biggest issue is that we certainly, when we're talking about drinking water, but water use as well, we want to be very, very careful about introducing new technologies. And really the same applies to industrial water, because basically not only the economics are at stake, but it's also public health, it is safety, security. So there's a lot of things at stake. So the value of water is much higher than the cost. And we understand that. And we are saying there's going to be a next war will be on water. That might all be the case. But we have to take this very seriously. We have to take concerns also very seriously. But there is room to accelerate the innovation of water. Yeah, and Paul O'Callaghan, the Blue Tech Research president, actually in his PhD thesis, he mentions an innovation cycle of roughly 16 years. And if you look at some good examples in the water industry, for instance, Nerida, that took almost that time to grow from the idea in the lab to a real application, and now is a really fast-growing wastewater treatment process, which is applied all over the world. Yeah. So, for instance, the new Jeddah wastewater treatment plant is a Nerida plant. Yeah. So that means this is applied all over the world. In desalination, there are even examples where the innovation acceleration was really happening very fast. So you could see that in 1960 there was the first patent on reverse osmosis, and the first application was early 70s already. And this was also driven by the fact that President Kennedy at the time recognized the need for desalination. So there's an interesting quote from him where he really recognizes the need for research and development and application of desalination. So you can see if leaders are really paying attention and see what is going on in their environment, then you can really accelerate. But that can only happen actually if you tie the academic innovations to industry. Yeah, because the scale up from TRL 3 roughly, which is as far as you can go in a normal academic environment, to TRL 9, where it's really tried and tested and commercialized, that is a huge step to undertake if you go by yourself. And I would say even in the low-level TRLs, the collaboration with industry is actually very important. And this is what you see, for instance, in the innovation model that is used at WETSUS, where sometimes even within one PhD research, you get to an innovation that is marketable. That is something that is really a good example of how you can work together, how you can bring academia, industry together, and end users together. Yeah, because industry in our case is the industry that actually delivers the equipment to the end user. Mm-hmm. And in some cases, they are the end user. Yeah, like in large scale desalination, the developers and constructors are most of the time the independent water producers.
What do you think, if you don't mind my asking, what do you think are the biggest hurdles of acceleration of innovation right now in the water industry?
I think it's the first step from bench scale to lab scale. Mm-hmm. Yeah, and that is quite simple because when I was at university, to be honest, there was still a lot of room for hiring people who were great with their hands and had a good set of brains. Yeah, so typically the highly skilled people. That has grown less and less. Yeah, and there's been a revival. I know at Eindhoven University of Technology, there's a big revival of bringing people into play that actually can make what others think about. But making the step to the pilot is a big issue. Now in the Netherlands, we are lucky to have an infrastructure, or let's say an environment or an ecosystem where you have the companies like Lentec, Jotem, Logisticon, those companies who are actually very well able to bring the idea from the lab scale to a small pilot that can be used on different locations and making the next step. So that is a very important, but in a lot of areas in the world, that is just not available. Yeah. We were in a situation when I was at KAUST that we had pilots made in Korea. And that is difficult because that does not allow you on a day-by-day basis just to look at the progress of the system and things like that. So globalization is interesting on the one hand, so at least you can get it done. But on the other hand, if you're really developing, then it's good that you have that ecosystem. And that is also why I think that also explains why the Netherlands for a long time has been in the lead in a lot of water treatment technologies. Yeah, simply because we had these enterprises, small enterprises, relatively, that were willing and able to do that specific work. Because a pilot is not a small scale practical installation. A pilot has much more than what you expect from, let's say, the end product. Yeah, because you need to measure more, you need to know more. There's relatively more sensoring and things like that. So, and recording of data. So that means that basically the skill and the mindset to build a pilot that gives you all the information you need, that is something that sometimes is missing. And having access to those companies, and I know you've been at Lentec, so you know what they can do. That is just great if you can have that, and you see in a lot of successful innovations. So let's say TU Delft partnering with Royal Haskoning DHV in an early stage for the Nereda project that really has moved this along very fast.
I totally agree. And from my side, I would like to see more commercial companies that have the ability to go from lab to pilot to commercialized system phase and be a one-stop solution for innovation instead of fragmentation of efforts, through like several different companies in order to take care of something. And this is another thing I would like to bring on the table. and mentioning a conversation I had with Eric de Sormeau in a previous video. And that's the problem, I think, one of the main problems in the water industry, fragmentation. We don't have collaboration and unified efforts in order to move forward. And we have big problems right now. And PFAS, for example, is a very nice big issue that can bring the industry together in order to find solutions. And you mentioned also the RO story that was developed back in the States. And this was, again, a unified effort that was cultivated from the governments in order to find a solution fast to a very big problem. So do you think that there's going to be moments like this coming, apart from PFAS, coming soon to the water industry in order to be unified and move forward faster?
What I see, and I think PFAS is an excellent example. PFAS is leading to more fragmentation. Okay. Because everybody is fighting to defend their own solution. And there is no common ground yet to value the solutions, right? Yeah, because you can say, well, destruction of PFAS is the ultimate solution. Yeah, but then you also have to look into what is happening to the side products and so on. So this also means that there needs to be at least a common ground at how you look to these technologies that are available. And with desalination is the great example. Why is seawater RO a success? Because very early on, these companies decided to have the 8-inch, 48-inch long standard for membrane elements. Yeah, and this is a bit the strange thing still about ultrafiltration, where there's still a lot of fragmentation there, where you cannot move from one manufacturer to the other unless you go for a Chinese replica, right? So that is also why UF is not gaining ground that fast as RO. So at least Exlo, now Pentair, has done their best to follow the 8-inch, 40-inch example from RO, and that really has made them very successful in the field. But this is happening across a lot of things, yeah. And it's not only that it's fragmented in industry; it's also fragmented in academia. So in some countries, you have several universities working on the same topics, basically competing with themselves, with each other, yeah, and showing a less of, well, not an optimal result. And as in my opinion, this is also a bit due to, I would say, rather the Anglo-Saxon approach, and the approach you now also find in Europe, yeah, so that we have to fight for funding, yeah, and to fight for funding, we are selling our own ideas, dismissing some other people's ideas, and not really getting to the true solution. Yeah, and water issues are overarching, are touching everybody. You could also say, as a government, we will give 3 or 4 of the leading universities just the objective and the funding to work together on a solution. Yeah, rather than competing with themselves. And I know I always, and in business, I've seen the same, by the way, you know, you can say, I have 2 companies fighting for the same stake, and I'm the holding company is the owner of both companies, and if I make them compete against each other, that's better for me. That is true if you have 2 dogs in a dog race, yeah. if you own 2 of the, 8 dogs in a dog race, then you improve your chances of winning. But in some cases, or rather most cases, it's a dog fight. So if you own both dogs in the dog fight, you end up losing. It's not a guarantee for winning.
That's a
No,
very
it's a
nice
guarantee
example.
for losing. Yeah. So, and this is, I think, happening in research as well. So you make researchers waste a lot of their time and effort.
Yeah.
Coming up with the research proposal. That's not granted, even though it was a very good idea. Yeah. And in some cases, a much better idea than the proposal that was granted. Yeah. And I've been through these cycles, and I've been able to bring in poor proposals, but sell them to an expert panel, where I said, well, really, this proposal didn't deserve the funding it got, right? But just because you can sell it does not mean it's a good proposal. And this is also something that needs to take into consideration. If there is a real big issue in an area or in the world or whatever, talk to the specialists, and do not allow people to sell a proposal, which basically, yeah, it's a good sale, but it's not a good proposal, right? And this is what is happening, and what I fear will be happening again and again and again. And you also have to think about that a scientist's reputation is mainly based on these Scopus and other criteria, yeah, which actually does not mean they ever solved anything. You know, my favorite question to visiting professors when I worked at KAUST was, how much water in the whole world has been treated with a process you developed or contributed to? And some of the most renowned professors actually had to be honest and say, none. And I do see it's not their task per se to design water treatment processes or to come up with new things. But at least they should train their students to make solutions, right?
So if do you consider that we should put more people in the ecosystem with a holistic experience, coming also from the commercial and system designing parts of the industry, in order to connect everything and understand where to put each technology and how to upscale it?
Yeah. So
something that you are
absolutely,
doing,
and
more or less.
Yeah. And there are some universities that make room for that. So they have bring in people for 2 years for a professor of practice role, right? Because that can make a difference, yeah, to bring industry experience into the research field.
And it's not only the universities, if you don't mind my saying, it's also low TRL technology providers who have found a solution, but they are having problems of bringing it into the market and upscaling it.
No, absolutely. That needs to be done. And so there is also yeah, and I know some companies in the past found that they have some kind of moral responsibility to help their startup companies that they see, and they say, well, these guys have something promising. Let's help them. They can be our future customer. They can be our future partner, or actually this can be a technology that is interesting for us. Now the problem is, and I've worked with GE for a while, GE Water and Process Technologies. The real big part is you see that basically your shop is getting so big that it's very difficult to maintain a good overview of what you can actually offer. Yeah, and this is happening. You know, currently, DuPont has taken over a lot of membrane companies recently, or in the last 5 years. So it's going to be very difficult to keep track of what is happening in each of the fields. So you have to have people, and that's a very special talent, that have the overview of what is actually happening. So, or also have the insight really to see opportunities, even though it's not really in their field. So creating that synergy between different entities in a bigger company, and this was my role when I was in GE. I was a function called synergy leader. That's nice. At the time, GE didn't want to have managers, so you were a leader, but not a manager. And then it's interesting to see how you can bring the newly acquired companies to market through your existing sales channels. And something similar needs to be done with innovation, right? And I'm supporting one company in the Netherlands in moving to market. And this company, Aran Solutions, is making membrane distillation. The path of membrane distillation has been very long. You know, the first patent 1963, and really it has not led to a breakthrough yet. However, situations are changing, and that is also something that you need to bear in mind. You know, I dismissed MD already 20, 25 years ago. Yeah, when they were still.
If you don't mind my asking, what do you
Yeah.
think is the main problem with membrane distillation that hasn't allowed it to catch up commercially up to now?
Yeah. So this is, I think, a very common issue with new technologies. Yeah. So for a long time, MD has been fighting against reverse osmosis. And that's a no-brainer, you know.
Why? Exactly, why?
Yeah, so this is absolutely nonsense. So, but then you look at what can you do with MD? It's actually, you can use waste heat to produce very pure water. So for seawater, basically one step MD, you get the quality of a double pass reverse osmosis.
But
So
is
that
it
is
easy
an
to use waste heat?
Oh yeah. That is not a problem, but in a lot of cases, it is rather invasive, because now there are cooling systems and an evaporator, condensation, everything. And then the heat is diluted to a level where you cannot use it. Yeah, so I also advocate that cooling is not the right terminology. Actually, it is dilution of energy to a point that you cannot use it anymore. So if you're able to connect before the cooling tower, then actually you can use that heat. And if you focus on those kinds of applications, so it's also, you know, for your technology, your new technology, look at the first real applications that can benefit from it. And for a long time, that has not taken place. So there are more applications that can benefit from it, but just to focus on the water side, there's really, if a company has excess heat and a shortage of water, or they can use very pure water, then MD is an excellent solution. And there are plenty of these applications, to be honest. And there's another issue. We are wasting so much heat. This is incredible, really. If we would use all the heat that is discharged into our rivers in the Netherlands by power stations, yeah, and if we would build MD, then we could actually provide the whole of the Netherlands with drinking water from MD. This is never going to happen, but it's just an example to show how much heat is wasted.
I like MD. Membrane distillation is actually the first technology that I ever used in the desalination space. Most people can come usually from the normal desalination,
the other side,
from the concentration of brine. But I guess that the translation of waste heat to usable energy for other processes isn't exactly that easy. Otherwise, it would have caught up by now.
Well, there are some issues. Obviously, there are issues with, for instance, the membrane element itself. There are issues with flux. There are issues with temperature polarization. But there are solutions for that, and the company that I'm supporting has actually found those solutions. And basically, if not for Corona, they would have already have a large-scale demonstration plant. But obviously, Corona changed a lot. So we're now moving again to a sizable demonstration plant, where we can show how to use this. And the timing is right, because in the Netherlands already drinking water companies are either not giving water anymore to newly established industrial companies, or are even planning to stop or limit the deliveries of drinking water to industry. And that is particular in the Vitens area, which is the largest drinking water company in the Netherlands. So I'm actually happy that they're doing that, because in the Netherlands, I'm in the Vitens area. So it's good that they focus on drinking water. But from an industrial perspective, obviously, it is a big issue. So if you have, for instance, you're in the food industry, and you're washing vegetables and freezing them, basically you generate a lot of heat, and you can use that heat actually to make water for the steam production, make water even for instance, freezing fish. Yeah, because you want to have a nice smooth layer of ice on the fish, so the fish looks fresh, So things like that. Timing wise, it's interesting now to look back at MD again, and this is not only at MD. So you have to sometimes take a step back and look behind you. What have I discarded? What have I done before to eliminate a technology from my list? A nice example, I was in Egypt at the EDS conference, and Toyobo presented their new type membrane element, which is basically based on the old style tricellulose acetate hollow fine fiber membrane. And now this membrane, the interesting thing is that you can use this membrane up to 40-45 degrees. And we showed before that above 38 degrees with the normal spiral wound thin film composite membrane, you get irreversible compaction above 38 degrees. So the fact, looking back at those old style tricellulose acetate membranes, could solve a potential problem that is quite realistic. Before the coast of UAE, the water temperature is rising and can rise in the coming years above the 38 degrees centigrade. So Toyobo might have the solution in hand for those kinds of situations. So that means we need to start testing these membranes now to make sure that they can solve a problem, and also to understand what the implications would be to use these membranes.
So just to come back to an earlier statement that we have talked again and again, and to state it out there, every innovation in the water space has a niche commercial space.
Exactly.
Not everything can solve the big problems, but
No.
there is definitely commercial cases. If you're a technology provider, there's definitely commercial cases for you out there. You don't have to save the world, but there is someone
Yeah,
out there
exactly.
who needs your solution.
And it's such a waste of time and energy and money in most cases to try to bring in your solution where it doesn't fit.
Mm-hmm.
Yeah, and this is, I think, what happened before, for instance, in MD, that they were just fighting the wrong battle instead of focusing on their real niche market. They were fighting against RO. It doesn't make any sense.
Pick your battles, huh? It's the same
pick your battle. Yeah,
it's the same. It's the same concept I'm trying to do with my toddler daughter. And
yeah,
it's you have so much energy to spend.
Yeah.
You have to pick your battles wisely.
And when I'm looking at proposals and also investment plans and so on, some of my clients are investors, and I'm looking at the pitch deck or other documents that support the request for financing. And when it starts, the global desalination market is $40 billion a year, then I'm already thinking, oh wait, you are a startup and you want to fight the big battle. No. Look at what can you address? What can you deal? What can you do tomorrow and day after tomorrow and next year? Not what is going to happen in 2050.
Definitely we need less hype and more common sense in the industry.
Yeah, absolutely.
And I believe people like you with holistic understanding of it can bring indeed more common sense engineering, as I would like to say.
Yeah.
People with a conceptual level of understanding, but they can connect the dots and make sure that something is viable long term. Paul, I would like very much to thank you for taking time out of your busy schedule for this conversation.
Thank you very much.
I'm pretty sure that we will find more chances in the future to talk again. But for now, I would like to wish you a good day. Take care of yourself. And we will be here to talk more interesting topics in the future.
Okay. Thank you. Bye-bye.
Have a nice day.